Hello. Now we will replicate the same analysis in the textbook. So we are going to define the variables in the same way as in the textbook. So we need to go through a few steps to do that. First, let's think about this. There are the class type. In the textbook, the class type is defined as small or regular aid. So small or regular aid are defined as a separate dummy variable, but the reference group is regular. So I explained how it works in the class. So to do that, to implement that, we are going to use the command generate. I'm going to generate a small variable, and I will define small variable as 0. Remember, one equality was definition. One equality means definition. So here I'm defining a new variable named small as and it takes 0 for all the observations. So generate, and we are going to replace small equals to 1 if class type k equals 1. So class type variable takes 3 different values. 1 is small, 2 is regular, 3 is regular with aid. So only when it equals to 1, then we make small takes 1. Take 1. So small equals to 1 only when it is 1. And also, you have to note that I use two equalities here because this is condition. This is not a definition, but it is a condition. So you have to use two equalities. Then you find 1900 observations take 1. All the other values will be still 0. So default was 0, and I replaced it in this way. And now, now I will define, in a similar way, I will define aid variable. In this case, class type variable, if class type variable equals 3, then aid equals 1. Otherwise, aid equals 0. So I'm going to define it this way. So let's see if it works. Yes, it works. But the problem, so what I did here is I generated aid variable that takes 0 only when class type variable is strictly smaller than 3, 1 or 2. So then what happened was like this. There are missing values. So those missing values happen if this condition is not met. Now what I'm going to do here is replace, you have to replace them to 0, and you may use like something like this. But just to show you, there is another way. If I will do it this way, if aid is missing value is denoted as 0 in this program. So if aid is missing, I'm going to fill 1 into that observation. So then this much observations are changed, right? Just to make sure, if this number equals to the number of class type equals to 3, count if. I'm going to check it. So it counts. The count comment is literally count how many observations have this variable equals to 3. It's a conditional variable, so a conditional command. So double equalities. Then you find the same number. So exactly same number of variable satisfies this or this, right? So we defined small and aid. So these two dummy variables capture the class type. And next, we are going to define free lunch. So free lunch variable is currently the information is in where sesk. Where was that? Uh, oh, here it is. This is socioeconomic status variable, so free lunch variable, and it takes some sesk. It takes one or two. One if a student is eligible for free lunch, and two if not. So what we are going to do here is I'm going to generate free lunch variable as 2 minus SSK. So, and then what it means is if it is 2, if SESK takes 2, then free lunch will become 0. And if SESK was 1, then free lunch will be 1. So if eligible for free lunch, then this free lunch variable takes 1. It is equivalent to something like this. You may do it this way, but I'm just showing you different ways of generating a new variable. And by the way, in this case, there are 24 missing values. For some reason, there is no information about 24 students. So that's that's a problem that happened in the data, and in our analysis, those variables will be dropped. We do not use them. And then next, the next variable the textbook uses is white Asian variable. There are in the original data there are 6 different races, but the race category is simplified into only 2 groups. One group contains white and Asian, and the other all the other groups. So I'm going to generate now white Asian equals 0 and replace white Asian equals 1 if the race, student's race, is in this variable S race, and if S race is 1, then white, or S race 1 is white and 3 is Asian. So 3 is Asian. So we would like to change this variable to 1 if it is 1 or 3, and or is vertical bar. You have to use vertical bar to denote or, and then you can do it like this. Or if you are not confident what is the or operation, then simply you can write it in 2 lines. S race 3. So there are only 14 Asian students, and most 4,000 students are white. So we defined white Asian, and the next variable is age. What's tricky here is we are going to use quarter of birth variable. We have birth year and birth quarter. And the age will be calculated at the time of as of say September, or enter at the end of August when they enter the kindergarten. So what I'm going to do here is, it's tricky, just think about this. I will generate like this. So in general, so we are measuring the age as of 1985. So excuse me, I generate age equals 1985 minus birth year. So that should be the age, but we have to replace if we have to take -1 if the quarter of birth is 3 or larger, right? So if a student's birthday was in the first or second quarter, then age is calculated like this. But if the quarter of birth is third or in fourth quarter, then because the birthday is not has not come yet, so you have to take -1, and we change the information in this way. So we define age like this. So age is defined as a new variable. By the way, these are the variables we defined so far. And attrition is generate attrition equals 0, and we are going to replace attrition if equals 1 if a student does not participate in the project at some point. So if star 1 takes 2. So, right, let's go back here. So as you see, star 1 is whether the student participate in the project at the first grade, and no is included as 2. No is 2 and yes is 1. So we say this student is treated from the sample. It removed from the sample. And again, we are going to repeat. We are going to do the same thing for the second grade and the third grade. So star 2 equals 2, or star 3 equals 2. So if no if the participation is no at the first grade or the second grade or the third grade, we will define the student as attrition. And using the sex variable, we will define generate girl equals 1 if sex variable equals to 2, and replace girl equals 0 if sex variable equals 1. So this is how we define the girl dummy variable for girls. And white teacher, the textbook uses generate white teacher, the race of the teacher, and it takes 1 if the t raised k equals 1. So t raised k is the race of the teacher in the kindergarten, and if it is 1, white teacher race takes 1. White teacher takes 1, and replace white t equals 0 if t raised k is not 1. So not is tilde equal, wiggle equal. So wiggle means not. So if not, it takes 0. And what else? And master degree. Generate master degree for the teacher takes 1 if HDEGK highest degree of the teacher is 3 or 4 or 5. So 3 is master and 4 and 5 are higher degrees. So if this is greater than or equal to 3, then master degree for teacher is 1. Yes. And replace master t equals 0 if HDEGK is smaller than 3. Then we are defining the master degree variable for the teacher. So this is all, and just to avoid digester, save it. I'll save it again, save, replace. And then we are going to use those variables to implement our regression analysis and calculating the averages. So we are going to do that in the next video. Thank you for watching.